Hi and welcome to DCO. My name is David Copete. Let me show you what we do in today's video. We start with an isotrim surface that then gets triangulated, but the idea for this was to be able to take a panel, subdivide it, and then apply this pattern to any scenario. So we start by creating the pattern, which is here with the base surface, subdivisions, and all of the details you see here. Now, this is a simple exercise, so you understand how to take isotrim subdivision and then turn it into this random triangulated pattern that has a minimum and maximum to kind of expand that pattern. So what you'll see is the beginning part, which is creating this. Then you'll see the cluster, which is nothing more than the entire script organized using the inputs and the outputs here. So with this simplified version, then we went ahead and created this exercise. Now this exercise is basically taking that pattern and applying it to a specific scenario. So in this scenario, it's a series of columns and a beam at the top that has a surface that then you can apply this entire thing to. So if we unplug this, you'll see that it's empty when we plug this in. Now we can play around with the number of subdivisions and also the minimum and maximum. And if we want them to be the same, we could do that. We could have it be 0.5 and 0.5. And so that's what you'll be seeing today. At the beginning here, I do want to have a conversation as to how this was done so you can see and understand how it was done at the beginning. And at the end, you'll see the entire work session of me creating all of these scripts. So if you have any questions, let me know in the comments below. And if you want to check out this script and download it and play with it, you can go to the website copetedavid.com. There you'll see this available for a limited time so you can play with it, see how it all plugs in, and add it to your library so you can use it in the future. So let's get into how this was done and let's talk about it. All right, so what we'll do to start is bring in a base geometry to subdivide. Now, what I like to use, you can use anything, is a plane surface. And when you bring in this plane surface, then I do like to put it upright, let's say against the wall. And so I'll use the XZ plane. So I'll double click here and bring the XZ plane. I'll plug that into the plane input, and now it moves it to orient to that plane. So now let's pick a size. We'll go 60 by 60, and obviously the cool thing about parametric design is that we can change the numbers and it could be whatever size we want. Okay. Now at this point, we're going to subdivide this panel. Now if you're familiar with Grasshopper, you know that there's other plugins like Lunchbox that lets you use all of these different types of subdivisions. But what I want to show you in this exercise is, if you don't have Lunchbox, how to do these patterns just using the default components that come within Grasshopper. So here, let's go to isotrim, which is the way to subdivide a surface without any plugins. Now we do need to bring in divide domain squared because that's going to determine the number of subdivisions. Now we have the plane as the surface, this plane as the domain input, and then the segments as the domain here. Now if you see that these are overlapping, is because we have the original surface, then we have the subdivided one. So we can take this one, right click and disable preview, or middle click and disable preview. So now here we have a surface that has been subdivided, but notice that it subdivides it by default 10 in the U and 10 in the V. So let's change that. We'll go 5 and then slide down, tap Alt to create a quick copy, or you can do Control C and Control V. And now we can pick the exact number of subdivisions. Okay. So now that we have the subdivisions, now we need to take this and turn this into a triangulated pattern. So what we'll do now is we'll take the subdivided panels, and if you hover over the surface, you'll see that we have 42 of them. So what we'll do is we'll actually just pick one, because if we can subdivide one, then we can do that to all of them. So we'll go here to item or list item, which out of the 40 items that come in, it's going to pick 0, which is the first one. Now we can take this and further subdivide this. So now that we don't have all of the panels, we have just one panel. Now we're going to deconstruct this. So let's go to deconstruct, derep, and basically explode it, because we need to understand how the points are organized. That way we can create one triangle in the first half and the other triangle in the other half. So there are different ways of doing this, but when you deconstruct it, you'll see that you have 4 vertices, which means it's the 4 points here. Now what we need to do is go to know how they're organized, which one's 0, which one's 1, 2, and 3. So we'll go to point list, which tells us how they are organized. So if we go to vertices into points, and you won't be able to see it because it's kind of small, so I'll right click on size and I'll just set it to, let's say, 2. All right, so now you're seeing how the points are organized. This is 0, 1, 2, and 3. So what we need to do is this. Let's see if I can sketch on here. All right, let's sketch on here. We're going to go from 0, 2, 1, 0, and then 0, 2, 3, 0. So let's do that. To do that, now we have the vertices. Now we know we have 4 vertices because it's 0, 1, 2, and 3. And so now we can pick whichever one we want. So we'll go to item, list item, and take these vertices, plug them into the input, but notice that it only picks 1. Now we're going to go down here and go to 2, 3, and 4. So if we look at it like this, this is point 0, this is 1, this is 2, and this is 3. And you can see it here. I is 0, 1, 2, and 3. So here we have those points. So to bring those together, we can use a polyline. So we'll start at 0, go to 2, and then 1. Now notice it creates this, but we don't need to create the last one because all we need to do is go to close, set Boolean to true. All right, so we got one triangle. Now let's do the other triangle. So I'll take this, tap Alt, and create a copy. And notice that it goes 0, 2 to 3, and this one went 0, 2, and then 1. So what we need to do is unplug this and plug in 3. So hopefully you saw that. Otherwise, we can always undo this and just go 0, 2, holding down Shift, and then 3. So notice that now we've triangulated or subdivided this triangle using the points of that panel. And now if we wanted to, I'm not saying that we're going to do this right now. If we wanted to, we could go to graph, and you'll notice that it'll actually triangulate all of them. So for now, we'll go back to not grafting it because we can actually use this now. So let's disable preview. Let's go back here. We don't need the point list anymore unless you want to recreate this polyline. Now, let's clean this up a little bit. All right, now at this stage, now we need to create the pop out of the triangle here. All right, so at this point, we got these two, but we also have the original surface. So what I'll do is I'll take this, disable preview, and now create a surface on or bound by that polyline. So let's go to boundary surfaces for both. All right. So now what we need to do is extract a point here. Now we can easily bring in an area component and get the exact middle. But one of the things I like to do is actually be able to move that point around. But with this technique, we have to be a little bit careful. So let me show you. We'll go to evaluate surface, use the surface as the input, and the point as the MD slider. Now I'll plug this as the input. And notice that it doesn't really do much, it kind of stays in the corner there. What we need to do is reparameterize. So it thinks of it 0 to 1, so about halfway here, and then bring it up, and then use this to kind of pick the center point. Here's the thing. Sometimes you want the exact center point, but the reason why this is cool is because then you'll actually be able to move the point around. And if you move the point around, you'll actually change the pattern. So once you find that location that you want, then I'll take this, tap Alt, and then use this surface as the input. So now we have two perpendicular surfaces or planes within those surfaces. And now we can take those points and move them perpendicular to the frame. Let me show you what I mean. We'll go to move, but we can't just move it in the Y direction, because a lot of times when we create this surface, we're going to apply it in whatever random order or whatever random orientation, right? So it's not going to be good if we use X or Y, because that's always going to be consistent. So what we have to do is work off of the reference plane that we have here. So what we need to do is use this frame, use an amplitude component, because we're going to be moving it perpendicular to this frame. And now we can use an amplitude and use this vector as the moving vector. So we'll move this point perpendicular to the plane, and now we can use a value, let's say 1.5, to move this out, or we can even have it move in. So if we said -10, we can move this out or move it in. So we'll do the exact same thing, not just to this one, but also to this one. So now we have 2 points. All right. So with these 2 points, what we'll do is we will extrude this polyline to the point that was moved. So let's do that. Extrude to point using the polyline as the base and the moved point as the point to extrude to. So let's try to disable the preview here, and you'll see that this goes in. And now we'll be doing the exact same thing, but to the other polyline. So I'll copy this down, take this polyline as the input. Notice that it's going to extrude to that point. So then we override it with the other point. So let's disable the preview on all of this. And now here's what I was talking about, is that now this triangulated pattern can move. And so it's kind of neat in the sense that you can have a dynamic pattern both by moving it in or out. Yeah, so we got this. Next, what we'll do is we'll actually have to go here and graft all of them. So now it will do it to all of them. And that's what I wanted to show you guys at the beginning, is that you can create and subdivide a panel. And if you keep everything in mind, you can apply it to the entire thing, not just to one. So here we are, we got the pattern, we got the panel. And the last thing here is, how do we make sure that this pattern is actually a randomized pattern? Because right now we have a subdivided triangulated pattern, but it's not random. So how do we use the random component and interject it here somewhere? All right, so what we have to do now is take a look at this. So if we look at this pattern, this amplitude component, or this amplitude slider, is the one that actually moves it in and out. So what we'll do is create a random set of these, but let's keep in mind a few things. Number one is, if we're going to create a random set of points, we actually need to create 100 of them. And then those 100 go both into this one and this one. So this is, as you can see here, just one number, and that is applied to everything. So to change that and create a random set, then we need to bring in a random component, because we need 100 different numbers plugging in here. So we'll bring this over here and plug it. We'll bring in construct domain, because we need to tell it the minimum and maximum number. So now we'll use 2 and -2. And that's going to be the range of numbers that we want to create. How many do we need? Well, we need 100 of them, and that's determined by how many times we divide this and this. So the other way of doing that is bringing in a list length component and plugging it into these polylines, because these polylines create these surfaces, and we have 100 of them. And we can change that, right? Like if this is 5 by 10, then it'll be 50. So now we have the list length here, but to get the number right, you need to flatten the input, because it needs to look at the entire list to give you the number. So now that we have that 50, and we can also multiply, 50 by 10, and then use that number here. And now C, there's going to be more random solutions to this random numbers. So we'll go here to 4, and we'll go back to 0 here. Here's why, because now it's all these random numbers starting at 0.7. Now if I change this, it starts at 0.96. So it's always going to change to a new solution here. So let's go to random as the input, but notice this. If I bring in a number component, an empty one, where I can plug all of these numbers into, notice that this is still not grafted. So we need to graft the output or the input so we can apply it to the pattern correctly. So what we can do now here is go to 0, and it's not going to randomize at all, and 0 here. But we can do minimum and maximum to be in and out like this. And now we can create new randomized solutions here with this slider. So the cool thing about this is that now we can bring this together and we can join it. Use brep join, flatten the input. And to be able to see it a little bit better, I do like to use a custom preview and a color picker, which is this one. Now we'll plug this into the material. I like to bring it back here because this is such a big component, but I do like this one a lot better than the other ones because it lets you change it just by, graphically without having to go into any other place. So now I'd also like to disable or hide the input preview. So let's do this. Let's move this around. Get into like a lime green. So notice that some are going in, some are going out, and they're all, let's say if we said 0.1, 0.1 enter, and minus 0.1 enter. Okay. Lastly, I want to conclude by showing you how we can just apply it to anything now. So let's move this. We applied it to a plane, and the reason why is because, well, that's the simplest base geometry we can use. Now, if you do want to do something a little bit more crazy, let's see what happens when you bring in a sphere and use that sphere as the input. So let's go here to 50. Now this sphere is going to be triangulated. So now let's disable the preview on the sphere and let's create more subdivisions. We can obviously change to more subdivisions this way and then more subdivisions this way. So do you see how cool it is to create a script in the sense that you've programmed everything that you wanted to, let's say one surface, and if you keep everything organized correctly, you can basically apply it to any surface. Now, I do see that there is a bit of an issue here. That must be the extrusions here because it looks pretty okay. Now maybe the minimum and maximum are just a little bit too much. All right. So now you see how to create a script using simple geometry at first, and then later on you can add complexity by using different subdividing or different base geometries. 10 by 10. So at the end here, you'll see this one, you'll see the original video script, then you'll see the cluster, and you'll also see the exercise. So there's a few scripts here for you guys to play with and to learn more about parametric design. And if you have any questions or got stuck somewhere, or maybe I skipped something, let me know. Otherwise, stay tuned for other videos. I do want to share more parametric tricks, more parametric designs for those of you who are interested in learning. So thank you very much for being here. Hopefully you learned a lot on this one, and let me show you the rest of the video, and I hope to see you also on the next one.